welcome back to YouTube channel Naren underscore here. We will move to chapter 2 linear functions, and the first section is section 2.1 introduction to linear functions. Before we dive into the materials, I wanna request everyone to like and subscribe my channel and share this video to your friends or your kids or anyone who is interested or who is a student at this level. Okay, let's focus on the main material now. We will be introducing the linear functions today. Okay, so let's start from the definition. A linear function is a function that can be written as y equals this function, which has expression of this form, mx plus c, for constants m and c. These constants are called sometimes parameters, or sometimes they are called parameters, sometimes they are just called constants. So any function that can be written in this form is a linear function. Now let's make some remarks here. So the main important points of this function. This form is called slope-intercept form of a linear function. Slope-intercept form. Slope-intercept form. Why is this called slope-intercept form? That is in point number 2. Is because here m is the slope of the line, because these linear functions are normally the straight lines, and this m represents here the slope and c represents the y-intercept. Y-intercept. Some people also call it vertical intercept. Vertical intercept. And this can be obtained, the c can be obtained by plugging x equal to 0 in the original equation. So if you plug x equal to 0, so you will get f of 0. Whatever you get in the original expression, you will get y-intercept. So this is one way of getting y-intercept. This is also called the initial value of the function. Why it is? Can you guess why it is called initial value? Because you are obtaining this value when you plug x equals 0. So initial value of the function. And this slope, this gives the measure of, it is the measure of average rate of change of f. Average rate of change of the quantity, whatever quantity is measuring, average rate of change of the function, or whatever quantity is represented by this function. M gives the average rate of change of f of x. Remember, in section 1.5 we discussed how to find average rate of change. Yes, it gives the same average rate of change. Now if I draw a picture of any straight line, so say this is this coordinate axis, this is coordinate straight line, coordinate axis and a straight line. So this part is called y-intercept. This is c, and this is the slope. This is the slope of the line. So this is slanted this fashion. Some line may go this fashion, some line may go this fashion, but here this point is called, this part is called y-intercept. Similarly, for other lines there will be other y-intercept, and this point is always 0 comma c. So in point form, y-intercept is written in this form also. Now you saw different lines going this way or this way, right? So what is the how to know what is the slope of the line? So if m, the slope is positive, your lines are always in this form. So their angle, this angle, sorry, I misdrew these lines. uh, let me redraw it. So if your m value is positive, positive means your slope value is positive, it means rise over run is positive, and this always represents in this type of lines. Okay, anything. And if m is negative, the line is always in this fashion. These are these lines have negative slopes, these lines have positive slopes. Okay, so these lines, so remember the nature of these lines. And the final so what is the important point to notice about it? So here, if m is positive, graph will rise. So graph is rising wherever you start, the graph is rising from left to right. Graph is rising, and the graph is falling here, or you may say graph is falling. You may not necessarily you need to draw these arrows, there is no point of drawing the arrows. The graph, if you start from here, the graph is right here, from left to right. The graph is falling from left to right in this case. And finally, fourth point of this equation is how to find the unit of slope, unit of m. It's very simple. This unit is equal to unit of y over x. And what is unit of c? Y-intercept. Unit of c is unit of y. Unit of y. Remember, c is the y value of the function when input is 0, and this is the ratio of the output over input, right? So this is how units are measured. Another thing, slope. Fifth point is slope. M is always rise over run. So what is rise? Rise is difference in y coordinates. So whenever you are, so vertical distance, right? And this is run. Run means difference in x coordinates. X coordinates. So this is horizontal distance. So vertical over horizontal. This will always give you slope. So these are the few points about linear functions, y equal to mx plus c. Now let's do few problems how to identify any given equation is linear function or not. So problem number 1, identify if it is linear function. Identify if it is linear function. If it is linear function. Linear function. If so, if it is linear, find m and c. Okay, so let's do few problems. Number A, y equals x square plus 5. So the best way to solve this is whenever you try to identify any type of function, you compare it with the standard form. What is the standard form of linear function? Mx plus c. So does it look like this? No, it is not a linear function then. So no need to go further. Number B, another function, 5x plus 7. Always compare with this. Yes, it is linear function, right? So when you compare with mx plus c, m is equals to 5 and c is equals to 7. So this is how we find slope and y-intercepts. And let's try to find another problem. So this is another. Now this is not in y equal to mx plus c form, but can we put it in that form? Yes, I think we can solve it for y, and to do so I will move 5x to the other side. So what do we get? We get 2y equals negative 5x plus 20. and if I divide both sides by 2, I get y equals minus 5x by 2 plus 10. I'm separating the fraction. So is this in mx plus c form? Yes, it is. And what are the values of m and c? Negative 5 over 2 and c equals to 10. So this is how we find slope and uh, y-intercepts. So what does this mean? So this, for example, if we take this, uh, okay, I have different problems for what I was thinking to do here. I'll do it in another type of problem. Okay, so for today, I'm going to stop here, and we will continue next time with more problems related with linear functions. Until then, please like and subscribe my channel, and please go through these concepts once again. Now, from this chapter, uh, from here, from every chapter, there will be introduction of new functions, so it will be very interesting. So do not miss my upcoming videos. Please uh, always to get notified, press the bell icon, and please subscribe my channel. Thank you for watching.